Yes, welcome everybody. I'm Futcher, Managing Director of Commercial Fuel Solutions, and in a moment I shall present to you today's session, which is how hydrogen could prove to be the future of cleaner backup power solutions and decentralized solutions. Could hydrogen be the future of cleaner backup power solutions and decentralized power? So I'm Futcher, Managing Director of Commercial Fuel Solutions Limited. As an accomplished engineer with a wealth of experience spanning over 27 years, working on a diverse range of refueling infrastructure projects, I've developed equipment for the British Antarctic Survey that can be used in sub-zero temperatures, and I've provided systems for leading Formula One teams. I also have extensive expertise in developing regulatory guidance, and I currently serve on a number of international technical committees for gaseous hydrogen storage and fueling, including British standards and ISO. So let's have a look at hydrogen's role in decarbonising backup power and grid augmentation. So presently, there's a large amount of conjecture within industry with regards to which technology will prevail in the race to decarbonise those sectors. Some will argue that battery electrification is the way to go, whereas others will fervently insist that CNG or hydrogen is a more appropriate solution. And many of these are in support of the application of biofuels like HVO and DME to use as intermediate solutions until low power emissions technology reaches maturity. The fact is, in order to meet the 2050 target of net zero, a combination of all of these and potentially new technologies will be necessary. So where does NRMM fit into the UK's carbon footprint? So NRMM stands for non-road mobile machinery, of which generators are classified. So in 2021, the UK emitted 5.6 megatons of CO2 equivalent, with the majority of these emissions coming from diesel machinery. The construction sector is the highest polluting industrial sector, with 46% of industrial non-road mobile machinery emissions coming from construction machines. Industrial NRM population is dominated by generators in the other sector. So as you can see there in the, just switch my pointer on, sorry. Here we have over 1 million other machines, mostly popular, and that population is mostly off-grid power generation. So if we want to break that down by sector, megatons of CO2e coming from each of those NRMM sectors. The largest is construction, representing 46.2%. That's 2.61 megatons of CO2e. Then we have mining, ports, waste materials, and other. And the aforementioned other is off-grid power, generally attributed to generators. So how do the power generators contribute to that mix? Generator fossil fuel consumption, approximately 2/3 of the overall fossil fuel consumption from power generators is attributed to these smaller generators. And this is important when we look at process changes or fuel switching options in order to decarbonize. Whereas the remaining third is attributed to these much larger power generators. So the question really should be, why are generators essential to decentralized energy supply? Also known as distributed energy systems, these refer to energy generation and storage systems that are located close to the point of consumption, rather than the centralized facilities such as large power plants. Electrical power generators are crucial for decentralized and backup energy systems, as they offer a flexible, scalable solution that can be deployed across various locations without the need for extensive grid infrastructure. These systems are particularly beneficial for remote or isolated areas when connecting to the main electricity grid is impractical or too costly for a temporary installation. Some good examples of this would include, obviously, construction, film and TV, festivals, and events. All of these require temporary installations. And of course, in addition to that, you also have static installations with the need for backup power. So generators can also be used to augment existing grid infrastructure and support those applications where the grid connection is still in need of reinforcement. What options are there that are suitable for replacement diesel generators? So effectively, there's lots of options. As I mentioned earlier, process change and fuel switching are amongst the most popular. But generally, the more power that the installation requires, the more attractive hydrogen becomes. So for those large number of small installations representing 2/3 of fossil fuel consumption, lithium-ion batteries are generally preferred. If you're below 8 kilowatts, then that's a tangible solution. There are other options as well with regards to process change, of course. But as you can see, as you go through as the power demand increases, hydrogen becomes more and more attractive, especially when you reach these larger installations on the end here. So what decentralized renewable energy storage options are there? As we mentioned, the use case will dictate the most appropriate solution. And in most instances, this will resolve to either lithium-ion battery, which is by far the most dominant battery choice, or compressed gaseous hydrogen. Both technologies have their unique advantage and are likely to play complementary roles in the future of sustainable energy systems. The following table compares a typical 20-foot containerized solution for both lithium-ion cells and gaseous hydrogen. You can see that gaseous hydrogen offers a much longer life cycle, and there's less issues associated with decommissioning and deconstruction of those materials used to store hydrogen. The life expectancy is also significantly better. And the energy density, the energy that can be stored within a 20-foot container of hydrogen, is significantly greater than what you would have on a 300 kilowatt battery. That's not to say that batteries don't have their place. I just want to emphasize I'm a proponent for decarbonization. Whilst I'm a technical expert on hydrogen, I do feel that batteries have their place, and both technologies have their unique advantages and are likely to play complementary roles in the future of sustainable energy systems. They have comparable costs, and the shipping weights, there is some discrepancy there, and this is due to the weight of the cylinders that are needed to carry the hydrogen. Where can hydrogen be applied where batteries are not necessarily an ideal solution? Currently, Scotland has approximately 10 gigawatts of wind farm power, but the grid can only transmit a maximum of 6 gigawatts across the border. So on windy days, this generation must be curtailed due to what's known as wind congestion. These events are caused because of the transmission bottleneck across the border. And as you can see from Rishi Sunak's speech on net zero September last year, it can take up to 14 years to build new grid infrastructure. And the chart here, which is from carbontracker.org, shows the red line is the current transmission axis, and the blue line is the expected projected deployment of wind turbines and energy available from Scotland. So as you can see, there's some disparity here, and it makes sense that rather than to curtail the production wherever this disparity exists, would be to lay down electrolyzer technology to convert those excess electrons rather than curtail the energy and convert that into hydrogen. And I would expect to see that in the near future as the technology matures. The next slide shows how hydrogen can solve this problem. With the aforementioned 8 gigawatt transmission expected to be in place by 2030, this still leaves the Scotland to England transmission shortfall of 25 gigawatts by 2030. Some of this otherwise wasted energy will be converted into renewable hydrogen using proven, scalable electrolysis technology. This model enables the storage and mobilization of excess energy to provide grid augmentation and off-grid power until such a time the necessary transmission infrastructure will be in place. So 1 gigawatt of wind power would be able to produce 400,000 kilograms of hydrogen. Just 10 kilograms of hydrogen is enough to power, dependent on your application, your use case, between 110 to 150 kilowatt hours of usable energy through a hydrogen powered generator. And there are other advantages to hydrogen power that complement the energy infrastructure, including sustained performance in cold weather, energy density, and the availability of raw materials. Hydrogen can also be used as a fuel source and an energy carrier within heavy industry, further increasing probability of uptake in these sectors. So how are commercial fuel solutions addressing this challenge? We have identified hydrogen as the solution to decarbonize our core customer demographics several years ago. And since that time, we've spent significant effort and resources on building supplier relationships and developing products to meet increasing demand for safe and affordable hydrogen storage, energy, and refueling products. Many of these are designed and engineered at our new Centre of Excellence H1, which is where I'm talking to you from today. Current hydrogen products and services from Commercial Fuel Solutions. We have mobile hydrogen refueling bowser. This is awaiting certification at present, and the final and then should be available for deployment early next year. And on the right, we have here our mobile hydrogen internal combustion engine power generator, 45 kVA. This is available now. So other products and services, nozzles, safety brakes, pressure fittings, valves, all important for building the necessary hydrogen infrastructure to enable uptake. So that's my presentation. I welcome you all to connect with either myself or our company account on LinkedIn, where you can stay updated with our announcements and the latest developments taking place within refueling standards, which we're helping to develop. And with data centers being significant consumers of energy, do you think hydrogen fuel cells will be integrated to provide a sustainable backup power solution? That's an interesting question, definitely. So I think it's when you look at energy storage and available footprints of the site, then yes, definitely hydrogen does offer promise. There is a lot of potential. Currently, the technology is cost prohibitive, but we anticipate uptake in other sectors like construction, for example, will stimulate the scale of economy or stimulate demand for hydrogen, which enables the scale of economy, and you will see more cost parity between battery storage and hydrogen storage solutions. Additionally, when you want to look much further ahead, long term, because data is going to be a very important part of our lives for a very long time, and the need for data centers is going to grow and need to be scaled. Then eventually, when you look forward 10, 15, maybe even 25 years into the future, by the time we start to encroach net zero 2050, hydrogen should be available by gas pipeline, secure, safe gas pipelines, which means then fuel cells are an obvious choice, especially if you have this excess energy challenge that is currently presented in Scotland. So yeah, laying down electrical cables, laying down pipeline, these are two things that definitely need to be done to be able to scale up electrical power, and whether that's mobilized by hydrogen or otherwise.
Hi, Robin. Sorry, I had some technical issues that meant I couldn't get on camera. Firstly, thank you for that, and thank you for taking that first question. I was going to present that question to you anyway, but I'll ask the next audience question, and I will say thank you for
no problem
for the discussion. I know hydrogen is still that technology that a lot of people are trying to get their head around. It's still a little new, but also not that new anymore. So I appreciate you for breaking it down so clearly. Right, the question from the audience is, how do UK government policies and funding initiatives like the hydrogen strategy and the net zero strategy support the adoption of hydrogen as a cleaner backup power solution? And what else should the government be doing?
Okay, that's interesting, actually. So there's a lot to unpack there. Let's start with government policies and funding initiatives like the hydrogen strategy and net zero strategy. Hydrogen is an important part of that, and I know it has been played down recently to address potential fears of its cost prohibitive nature. I think ultimately, if you wanted to look far ahead into the future, again, looking at our net zero 2050 targets, then they are difficult to achieve. They are very ambitious. Let's be honest. You require not only consumer uptake and adoption of carbon saving technologies and even methods, ways of working, like walking to work, cycling to work, everything. A large number of small changes will actually make a very big difference. But ultimately, if you look at the UK, if we want true energy security and we want to maintain keep the lights on effectively, and we want to have power, then our energy consumption is not linear. We use more of our energy during the colder winter months. This is for lighting, this is for heating, this is also for cooking, and of course travel. You're more inclined to take a journey in a motorized vehicle, maybe even an electric car potentially, as opposed to in the summer when you may walk or cycle, or maybe even rely on public transport. All these use cases are very different, and it depends on who you are, what you do, and everything along those lines. But effectively, if we did have enough linear energy coming in from renewable sources, whether that's Scottish wind farms or new projects, or even potentially other energy production methods that are yet to materialize at scale, then ultimately hydrogen offers a very valuable storage asset. It's much better than laying down tons and tons and tons of lithium-ion batteries. Even if there were no challenges over the ethical element of retrieving some of these materials or the scarcity of some of these rare earth metals, then inevitably hydrogen still offers you better solutions when it comes to energy storage. So hydrogen will inevitably play a future in this. And if I wanted to just give you a good example of how hydrogen would be applied in industry, so the aforementioned non-road mobile machinery market that I mentioned there. Let's take construction. So if you have a construction site, you're a construction operator, you get your planning permission, the first thing you do is you send in your heaviest machinery to flatten the ground and dig the foundations. So even if that machinery could be electrified, which some of it can now, absolutely, then ultimately, how are you going to be able to recharge those 260, 500 kilowatt hour batteries without the power of hydrogen? You're going to need a diesel generator to generate that energy, because it's unlikely that there'll be an immediate sustainable grid connection. Additionally, and that won't always be the case, of course, but for the moment, for the immediate short term, then that's a good example. And I think as well, how can we encourage the government? So obviously, we're potentially going to see a change in government soon. If not, maybe whatever happens, there's a lot of uncertainty at the moment, and this makes people nervous. You don't see government departments, or whether it's BEIS or DESNZ, sorry, you don't see much action taking place. You know, they're all waiting to see what really happens, and what policies were going to be brought, what new mandates are going to be in place. So what you have is effectively a concern where nothing's happening at the moment. But what I would really like to see, to be honest with you, is I would like to see whoever the next term of government, whoever it is, I would like to see them rethink their current modelling of funding and grant structure. Not only, I think what they've done is great. Let's take the ZERF fund, the Zero Emission Freight Demonstration Fund, for a moment. So they pumped 200 million into zero emission freight demonstration trials. Some went to electrification, some went to hydrogen. And this is great because it helps encourage uptake, and it helps stimulate technology. But ultimately, the problem you have is transport operates on a very, very thin profit margin, maybe 2 to 5%. So even if these trials are successful and they're demonstrated at scale, then the real challenge is it's not going to be affordable. It's still going to remain cost prohibitive for a large number of operators. And what can effectively happen? So what I'd like to see the government do is, rather than throw 200 million again at transport, I'd like to see them make low interest bearing loans available to plant operators, people willing to invest in decarbonized technology. The reason why I say low interest bearing loans is, of course, interest rates have gone up rapidly quite recently. This has impacted a large area of business. But more importantly, what many people won't be aware of is that over 2/3 of all plant hire or of all construction equipment is hired by the operator. It's not owned by the operator. Construction have much deeper pockets. They will pay these rentals. These rentals could then be used if the government made this funding available. And we are talking to UK Hydrogen and KTN Innovate and the Department for Energy and Net Zero about this at the moment. But realistically, if we could make low interest bearing loans available to people willing to invest in this hydrogen and decarbonisation technology, not just hydrogen, but also electrification, then this would stimulate uptake. It would encourage those plant and fleet operators to embrace that technology on a short-term hire, to experiment with it, to trial it, to test it, to prove it. And then I'm confident that it would be seen to be working, in which instance, then you're likely to see wider uptake elsewhere. And this is how you effectively solve this. I hate the cliche, but it's a chicken and egg situation with regards to hydrogen deployments. So hopefully that answers your question.
I think you're seeing the same thing regarding heat pumps. They're colossally expensive, and the government throwing these grants out at people, and all of a sudden the uptake has ticked up slightly. And hopefully with the chicken and egg situation, like you mentioned, heat pump prices will come down because more people will be buying them. And that's sort of the same sort of situation here, in terms of, if people try them, then more people will eventually make that transition.
Yeah, completely. You're right there, Jordan. Look, I mean, I'll jump into the other questions in a moment. I can see we have a few moments left.
Yeah.
But effectively, look at electrification of passenger cars. For a long time, electric cars have been around for a long time. For a long time, they were policy-led. They were always policy-led, need to decarbonize, green agenda, this, that, and the other. But now consumers are behind it. There's a huge uptake. And this is what has effectively caught everybody off guard, because now the younger generation, and actually, I don't want to be ageist, but people of all ages are really behind a lot of people have environmental policies intentions. So I think if you had two comparable products and one was greener than the other, people would opt for the greener one. It's only when you see that cost disparity occur that you see people start to question that change, and I think they have an appetite for it, but it's making it affordable. And I guess that kind of answers the next question that's in the chat, asking about, does cost potentially deter adoption? What are the best arguments? So crack on, Jordan.
I think it is also important to highlight that hydrogen isn't necessarily clean, since there is a whole rainbow of different types of hydrogen, whether it's white, black, green, grey, pretty much everything in between. So if a company is going to adopt hydrogen as the fuel for their backup power supply, how do they ensure that it meets their environmental goals?
Okay, well, that is actually a really intelligent question. Thank you. First of all, I will state I'm not a fan of this unofficial color spectrum. I actually sit on the International Standards Committee for Hydrogen Quality, and feedstocks, production pathways are not relevant. But what is important is your carbon pathways. So I think what is qualified as low carbon hydrogen here in the UK's low carbon hydrogen standard is different to what you have in Europe. It's different to what you have in North America. It's different to what you have in Asia. So I would like to see some linearity across those low carbon hydrogen standards, so there's no ambiguity, no confusion. In fact, if you believe it or not, the Clean Hydrogen Partnership, I think that's their name, in China, actually classify what we call grey hydrogen here as low carbon because it's made using gas. However, it's
Yeah.
important to note that the majority of hydrogen produced for commercial applications like ammonia production, plasticizers, fuel desulfurization in China is made using burning coal, which has almost 2 times the carbon footprint of gas equivalents.
Yeah.
That's why they call their clean hydrogen what we actually consider to be dirty hydrogen here.
Cleaner
Yeah,
hydrogen, I guess.
indeed. And I think it's important for people to recognize the impact. So it's not always about production as well. Sometimes it's, I mean, it's like driving a car that's been charged off of the grid. A car will typically do around about 0.2 kilometers 0.2 kilowatts per kilometer. And if you were running that same car on grey hydrogen from the grid, although it needs purification because there's challenges with gas reformed hydrogen to do with sulfur compounds. I won't get into the technical discussion of that right now, but basically what you have is a comparable carbon footprint, EV charged on the grid versus a fuel cell running on gas reformed hydrogen, gas reformed fossil hydrogen. So yeah, absolutely. I think it's important. You need to have awareness and you need to be aware of it. But all of this, whilst it might not be perfect, I think it's a good step towards mobilizing that energy. And even if we can build infrastructure in other ways at the moment, it gives us an opportunity to refine that and improve it further. And the same applies to like EV cars. So EV cars are great. If everyone drove them, we'd still need to power them off the grid because there's not enough green electricity available. So it's the same thing. We just need to embrace the technology, drive consumer change, and then everything will build out from there.
And I think you've sort of touched on the next question in terms of, as more renewable energy sources get on the grid and as more renewable energy sources become available, obviously hydrogen will be cleaner. And that's sort of what the question is how do hydrogen fuel cells integrate with these technologies provide a more reliable and cleaner backup power solution, which I guess you've answered 5 times over.
Yeah. I mean, if anyone's got any other questions, obviously I'm happy to field them. And with regards to that final one I can see there.
The skills gap, which is a very common question. I'm assuming everyone comes across it in the industry.
Okay, so I mean, we're actually looking to lead by example. I'm sat here today in our training room. It's very quiet because it's just me in here at the moment. But effectively, we are offering we're looking at upskilling existing technicians from within the oil and gas industry, and so everybody from auto mechanics to training them to operate on fuel cell vehicles safely, of course, and compressed hydrogen storage systems. But additionally, when you look at oil and gas petrol maintenance engineers, they understand the intricacies of hazardous area formation, correct equipment selection, how to permit to work in these unsafe areas or potentially hazardous areas. So there is a lot of skills crossover. And if I can just offer some insight from a personal perspective there, I've been doing fuel systems for 27 years. I've been studying hydrogen intently for about 8 years. I would consider myself a hydrogen professional for maybe 5 years now. And it was easy for me to transition skill sets that I'd learned regarding equipment selection, valve selection, flow coefficients, fluid dynamics, hazardous area classification, electrical circuits. A lot of those skills were transferable and just needed a small amount of refinement and adjustment to get to where I am today. So hopefully that's illustrative of the ability of people being able to adapt existing skill sets and migrate them into this new, not just with hydrogen but renewable energy as a whole. I think and if nothing else, what we'd also like to do is motivate the younger generation to really embrace these opportunities in engineering. So STEM is very important: science, technology, engineering, math. If you can get out there and encourage your kids to design something, to build something, to hopefully create a better future for us all, then great.
Perfect. Thank you, Robin. I'll let you go now. Thank you again for that presentation.
All right. Fantastic. Any questions, please reach out on LinkedIn or email me. That's great. Thank you.
Thank you.